We now look at stationary points. Stationary points are points such that dy dx is 0. So we say f has a stationary point at x equal to c if dy dx is equal to 0 at x equal to c. And there are three types of stationary points: local maximum, local minimum, and saddle point. Local maximum will look like this. That means the gradient here is 0. You draw a tangent line at the maximum point, dy dx is 0. So dy dx is 0 here. And then for minimum point, if you draw a tangent line here, dy dx is 0. And then for saddle point, you'll find that you draw tangent line, the gradient is 0. So although the gradient is 0, but you don't have turning point, you don't have maximum point, minimum point. So saddle point is just point with dy dx 0, but it's not maximum, it's not minimum. And we are going to look at first derivative test. You can use dy dx to test for maximum, minimum point. So we call it first derivative test because you use f prime x to test. Suppose C is between A and B. And if you know that f prime x is positive for x less than c, for x less than c. For x belongs A to C means x is here. So if here f prime is positive, then f prime is negative for x mod. For x here, f prime is negative. Then you have local maximum. As for the other way around, right? If you have the other way around, meaning if you have f prime x is negative for x less than c, and f prime x more than 0 for x more than c, you get local minimum. You note that in either case, f prime x changes sign. For case 1, to get maximum is changing from positive to negative. And for local minimum is changing from negative to positive. So we look at why this is so. You'll find that if f prime is positive, you will have positive gradient. Positive gradient will look like this. Tangent line must have positive gradient. So it must be something this way. Then if f prime is negative, it must be something the other way. So you find that from positive, then gradient becomes 0, then becomes negative. So we get maximum point. That's why if f prime is positive before x equal to c and negative after x equal to c, then you should see tangent line, the gradient changing from positive, 0, then negative. So with that you get local maximum. Let's look at the other case. So at c, f prime c is 0. Before c, f prime is negative. If gradient is negative, means you draw tangent line, it must be something this way. So negative gradient, f prime negative. Then after c, if you draw gradient, tangent line is positive. So with that you see that you get local minimum. So f prime changes sign from negative to positive. So you have a local minimum. So that's how you have the two conclusions here. If f prime changes sign from positive to negative, local maximum. If f prime changes from negative to positive, local minimum. And you can use this to test for local maximum point, local minimum point. As for saddle point, you'll find that gradient will not change. Here you have f prime c is 0, but before c and after c, the gradient is the same. So before c, after c, the gradient is the same. Before c, if you draw tangent line, it's something this way. After c, tangent line is still the same. So no change in sign of f prime. So does not change sign will give you saddle point. So this is negative before c, after c also negative gradient. So saddle point means f prime c is 0. C is a saddle point if f prime c is 0, but f prime does not change sign.